Welcome back, everyone, for part 2. I did kind of accommodate my expectation for the remote folks today, so within this packet I also go on to cotangent and tangent, which we haven't looked at. So I just want us focused on cosecant and secant for today. So I'm going to go through 2 pages, and then hopefully we can do the third independently without Desmos. And then we'll talk about cotangent and tangent when you come into class on Monday. All right, so the first kind of thing I wanted to highlight here is, we're getting these asymptotes, and it's like, why is that happening? Or why does this graph just shoot off towards infinity? And that's because, on my unit circle, so secant ends up being, this is hypotenuse over adjacent. And so secant of some angle is that. What happens when this adjacent side becomes really, really small is we end up needing to divide by a smaller and smaller number. But on the unit circle, our hypotenuse doesn't change. Our hypotenuse is always 1. So if we consider basically what's happening there is initially I start out with this 1 over 1, which is 1. And then as I move my way around the unit circle, or as this kind of changes, our adjacent side, not what I want. Erase, there we go. Our adjacent side gets smaller and smaller. Okay, so it was 1, and then I end up with 1 divided by, it's going to become 0.5, which then gives me 2, and eventually this number starts to get closer and closer to 0. Okay, and what we can see based off the pattern of these numbers, 1, 2, 4, 10, is that eventually this is just going to keep kind of skyrocketing. Okay, so 1 divided by 0.01 is going to end up giving me 100. So as the denominator gets closer and closer to 0 and the numerator doesn't, that's why I end up kind of approaching infinity at those points. And that's a pretty important concept to just kind of recognize, that when a denominator approaches 0 and the numerator doesn't, that is pretty much a recipe for having a vertical asymptote or shooting off to infinity on our graph. Okay? All right, so here you'll see that it's kind of phrased a little differently. I didn't leverage it by saying, graph 3 sine of a half x plus 1 first, but that is what I need to do. So we can, need graph of 3 sine half x plus 1. So I need that first, okay? And similar to last time, I might even start this with my basic kind of sine graph first, just so that I can see these points, and then that helps me manipulate them. So I'm going to put those in. Okay. All right, so 3 sine half x plus 1. So my period is now going to be 4 pi, because it used to be 2 pi. And again, we've got that relationship where period for sine, cosine, is 2 pi over b. So 2 pi divided by a half is actually going to give me 4 pi. So I'm actually stretching this graph out. I'm moving it up, and it's going to be kind of multiplied by 3. So all those kind of need to take place. And I might just try to do 2 of those for right now. So I'm going to just focus on the period change and the amplitude for right now. So amplitude switching to 3, and then so this is going to take until 4 pi to kind of fully complete. And then since my amplitude is 3, halfway in between those, I'm going to be up at 3 and or negative 3. Okay, so I did not do anything with my midline just yet. So all I did was my period change and amplitude change. So that guy's going to stay put. This guy's back here. So then, in order to finish this off, and maybe I'll just go with kind of highlighting this in orange, and then I'll do my graph in orange. So I'm almost there. I just need to take that purple graph and move it up by 1 unit everywhere. So I have all those points kind of pretty clearly on there, so I'm just going to move them all up 1. And again, that fits with my order of transformation, so if we don't lose sight of that knowledge. This graph also should not cross that purple graph anywhere, so that's kind of to be expected. So I end up with this. You might not kind of have this full luxury. Yeah, so this is kind of exactly what it is. So in order to kind of finish graphing this, I'm going to have my asymptotes. Because of that last like +1 shift, that takes place a little bit later on in my 3 cosecant graph, which is why I want to kind of do this example. So here, we'll notice that the asymptotes are still at the x-intercepts of that purple graph, okay? Or they're still halfway in between our sine maximum and minimums. So here, I'm still going to have asymptotes for 3 cosecant 1/2 x plus 1. So I'm going to put those in. Good, and then I'm going to put in my last one here. So those are my asymptotes for 3 cosecant 1/2 x plus 1. And then to finish this graph, this is where I'm going to go down and just try to like kiss or touch that 3 sine 1/2 x plus 1 graph, which is in orange. All right, so I chose kind of this blue. So this is going to come down, touch, come back up like this, come up, touch, back down. Okay. And then finishing that one off. So the different kind of thinking here, or the part that's a little bit tricky, is where our asymptotes are. If you think of them as in between the maximum and minimums on sine, that's probably going to help us out a little bit. And I don't expect you to do this on your graphs. Like this is probably what I would expect your finished graph to look like, and or maybe even somewhat simplified if you didn't want to do some of those graphs in the middle. But I could also, we could erase the like graphs that we were doing to build it. So if somebody was really wanting to see what the graph of 3 cosecant 1/2 x plus 1 looks like, it would just be that blue graph that I have left over. All right, we're going to do one more example and then see if you can kind of practice. These last ones, relatively involved kind of by the looks of it. And maybe I'll even, let's see. Actually, no, that's okay. I was looking to see if they had like any crazy period changes or anything, and I don't see those. So it should be okay for you. Definitely still challenging, but hey, that's what math's all about. All right, so I need to graph secant of x plus pi minus 1. So in order to do that, I really want my graph of cosine of x plus pi minus 1. And if I can graph that, then I should be able to complete the secant of x plus pi minus 1 graph. I'm going to start with just cosine graph. So this is without any transformations. This is what I know cosine to look like. It starts at 1, and it still has a period of 2 pi. Okay. All right, so then if I have to do cosine of x plus pi minus 1, this plus pi right here is going to move my graph to the left by pi units. So pi ends up being 2 of these spots, right? I can kind of see that on my x-axis. So I'm going to move every point that I have left by 2 lines, and I'm going to move it down 1 at that same time because that seems kind of manageable to do all at once. So I'm moving this, I'm taking this point, which is my y-intercept, and I'm moving it to the left 2 lines and down 1. So that is kind of the new point there, and I don't actually want this here because that's going to confuse me later. All right, so my orange points are really what I'm going to be kind of connecting to one another. So left 2, down 1, every point, left 2, down 1, left 2, down 1, left 2. And then this point. So that might have been kind of visually hard to see, but take all those little red dots that I have and just move them left 2, down 1, and then we end up with this graph so far, and then I just kind of need to finish moving all my left 2 down 1s. Could also like take that pretty basic cosine behavior and then just draw another cosine graph basically a little bit lower and to the left. And that strategy actually helped me do that one a little bit quicker. All right. So similar to our thinking last time, halfway in between our maximum and our minimum here on our final graph, we're going to have these asymptotes. All right, draw. And then to finish up my graph, I just kind of need to do the partnering sides of that, okay? So this guy's going to come up, touch, come down, touch, go up, and then so on and so forth, and complete that graph. All right, so that blue line is the graph of secant of x plus pi minus 1. So you've got 2 graphs to do. What I would say is attempt them at the very least, kind of independently. So for this one, you need to graph 2 cosine of x minus pi over 2 minus 1. And if you wanted to, let me just see if I can make this slightly easier. Like, if you want to, for this one, you can take off the minus 1 just because I don't need to make anything overly difficult for you independently. And similarly here, why don't we think to also, let's get rid of like this minus pi. If you wanted to and you're still listening to this video, you can switch this to just this. This is slightly changed, so like on the bottom here, so cosecant, this is actually, we need to be able to graph 2 times the sine of x minus 2 if you're using the adjustment. Yeah, but see how that's going to go, and then try plugging these into Desmos to see what you get. So we should have kind of 6 completed graphs when we return in on Monday, and then we'll take a look at tangent and cotangent. Thanks.